Okay, so these next few, if you've had an easy time so far, or if you've comprehended what we've done so far, should be pretty simple. I'm talking about 6 and 7. 8 should be pretty easy. We'll check out 9 and 10 later, but let's try to just knock out 6, 7, and 8 really quick here, because they all functionally are the same thing. They're all asking us to go through a list and do something, right? So let's do exactly that. So this is telling us to write a function sum of squares. So define sum of squares, and x is, which is not a very good. I'm going to continue to use nums as the variable for my my list here, because I know that the list that I'm going to accept in sum of squares should be a list of numbers. They use x's, essentially, xs meaning x's, so a list of x is, essentially, which is kind of a, I think, ridiculous variable name that makes no sense. So I'll just keep using nums. So I hope that's okay with you guys. So define sum of squares, iterates through list nums, and adds and returns a sum of the squares of the list elements. There we go. There's our docstring. Okay, so let's knock it out. So for I in nums, and then because we're returning a sum, obviously we're going to want to do an accumulator pattern. So for I in nums, sum plus equals I squared. That's it. That's all. Return sum. That's the entire function. That's all we need to do. It really is that simple. So we're iterating through the list, each item in the list, and we're setting the sum equal to itself plus the square of whatever the current element is, and then returning the sum. So that's really is truly all we need to do. So let's print sum of squares, and I'll pass in a list to sum of squares here. Let's do their example was 2, 3, 4, so let's do 2, 3, 4, and it should return 29, and it does. That's it. It's all nice and easy. This next question here is similarly very, very easy. So def sum of neg ints is what I will do. So, well, it doesn't have to be ints. Sum of neg nums. There we go. And I'm going to continue to take nums. So it says sum up all negative numbers in the list. We only want to sum the negative numbers in the list. So again, we're going to use an accumulator pattern. So sum equals 0. And then we're also going to use for I in nums. And we're also going to, at the end, return sum. So what do we need to do to the sum? When should we increase the sum? Well, we should increase the sum if the number that we're looking at is negative. So is I negative? Is I less than 0? If I is less than 0, sum becomes equal to itself plus I. Apologies for the dog. I think the mailman has arrived, and he hates the mailman. So for I in nums, if I is less than 0, if I is negative, add it to the sum, then return the sum. So let's do an example. So print sum of neg nums, and our list for sum of neg nums is going to be 42, 103, negative 2, 87, sorry, 76, then 87, then negative 5. So this should go through this list and only add together the numbers that are negative, which in this case is going to be negative 2 and negative 5, so we expect this to be negative 7. And it is. Very nice, very easy. Let's see their answer, see what it goes. Sum negative a list, sum equals 0 for element in list. If element is less than 0, sum equals sum plus e, return sum. So theirs works exactly the same as ours, except they're doing a random list, which obviously we have no way of telling whether or not that's actually correct because we can't see what's in the list. But because we have a defined list for ours, we know that it is in fact functioning correctly. So there we go, -7. Okay, so number 8. Count how many words in a list that have length 5. So this is very similar, even though before we have been working with lists of numbers, and this one is a list of strings. It's very similar to what we've just done in the last couple. So let's go ahead and start by defining our function. So I'm going to call it count5. I'm going to take a list of words called, in this case, words. And so I'm going to iterate through list words and return a count of words with a length of 5 characters. I think it's explicit enough. Okay. So we are going to want to do an accumulator pattern. So count equals 0. And then we're going to want to obviously iterate through our list. So for word in words. And then we need to think, when should I increase my count? Well, I should increase my count if I get a word that has a length of 5. So if word has a length of 5, so if length word equals 5, then we should iterate our count variable. So count plus equals 1. And then at the very end, we'll want to return our count variable. So return count. All right, and let's get a test statement going. So print count 5s, and then our list needs to have a few words, so which should be 5 letters long. So let's do hello is 5 letters, and world is 5 letters. Let's see, what else can we do? We can do strings, which is 7 letters. We can do words, which is 5 letters. We can do word, which is 4 letters. And we can do think, which is 5 letters, and Python, which is 6 letters. So we have 1, 2, 3, 4 words that are 5 characters long. So if we run this, we should expect it to return 5. And I have I had one extra quotation mark in my doc string. Be careful not to do that. And there we go, 4 for each of the words here that we have. Hello, world, words, and think are all 5 characters long, so it returns 4. So as you can see, is basically the same thing as what we did in this one, except with a different test case. Up here, we were checking to see if the item was less than 0, and here we're checking to see if the item has a length of 5, but they are functionally doing the same thing. They're iterating through a list, checking to see whether or not the item in the list fulfills a certain qualification, and then adding to an accumulator variable if it does. So these next couple I think are a little bit different, but we'll check them out in the next video.